Have you already lived your final day? Not in some distant future, but right now, as a fact already written into the structure of reality. According to one interpretation of modern physics, the answer might be yes. And the moment you're experiencing as the present, this exact instant, may hold no special status at all. This idea is called Eternalism. It comes not from mysticism or speculation alone, but from the mathematics of Einstein's relativity, the same framework that lets satellites navigate and that has passed every experimental test thrown at it for over a century. Eternalism makes a single, startling claim. Every moment in time, every event that has ever happened and ever will happen, exists. The past has not disappeared. The future is not waiting to be created. They are simply located somewhere other than here, in a dimension we cannot step through at will. If this is true, then your birth, this moment, and your death are all equally real, coexisting in a vast structure that does not flow, does not pass, and does not change. The sense that time moves, that one moment gives way to the next, would be something your mind constructs rather than something the universe does. Over the course of this video, we will examine where this idea comes from, what physics actually says, and what it might mean for how you understand your own existence. We will look at the evidence, the competing models, and the open questions that remain unresolved. The goal is not to convince, but to follow the reasoning as far as it leads, and to see what stands at the end of it. To understand eternalism, we have to begin with a question that sounds almost too simple to ask. What is time? Most people, if pressed, would describe it as a kind of movement. The present moment slides forward, the future approaches, becomes the now, and then recedes into the past. Time flows, the way a river flows, carrying us along with it, whether we like it or not. This picture is so deeply built into ordinary language that it is difficult to even speak about time without invoking it. We say that time passes, that the days go by, that moments slip away. The metaphor of flow is everywhere, woven so tightly into how we think that it rarely occurs to us that it might be wrong. But consider what the metaphor actually requires. If time flows, then it must flow at some rate. A river flows at so many meters per second. A current has a speed. So how fast does time pass? The only answer available is that time passes at 1 second per second, which is not a rate at all. It is an empty statement, a tautology that tells us nothing. Compare it to asking how fast a road moves as you drive along it. The road does not move. You move along the road. The sense of motion belongs to the traveler, not to the landscape being traveled. This is the first crack in the familiar picture, and it is worth sitting with, because once you notice it, the idea that time itself is doing something starts to look less obvious than it seemed. Physicists, when they describe the universe at its most fundamental level, do not find any flow of time in their equations. The laws that govern the motion of planets, the behavior of light, the interactions of particles, all of these laws treat time as a dimension, a coordinate, much like the 3 dimensions of space. In the mathematics, time is an axis along which events are arranged. It is not a process. Nothing in the fundamental equations marks out a particular moment as the present, and nothing in them describes that present moving from one instant to the next. The equations would work just as well run forward as backward. They describe a structure, a layout of events, not an unfolding. This is where eternalism enters. The eternalist takes the physics at its word. If the equations describe time as a dimension, and if they contain no flow and no privileged present, then perhaps that is because reality itself contains no flow and no privileged present. Perhaps the universe is not a movie being projected frame by frame, with only the current frame lit up and real. Perhaps it is more like the entire reel of film, every frame already there, every frame equally real, with the sense of a single illuminated moment being something that happens inside conscious observers, rather than something that happens in the world. The technical name for this structure is the block universe. Imagine for a moment that you could step outside of time entirely and look back at the whole of existence from some impossible vantage point. What would you see? Not a flowing river, not a sequence of moments being born and dying. You would see a single, vast, unchanging object extended in 4 dimensions. 3 of those dimensions would be the familiar dimensions of space, length, width, and height. The 4th would be time. And within this object, every event that has ever occurred would be present, fixed at its own particular location. The dinosaurs would still be there, roaming a section of the block tens of millions of years thick. The construction of the pyramids would be there. Your own birth would be there, at one set of coordinates, and your death at another. None of these events would be happening. They would simply be the way the different cities on a map simply are, all present at once, none of them more real than the others, merely because you happen to be standing in one of them. The map analogy is worth pressing further, because it captures something essential. When you look at a map of a country, you do not think that the city you are currently in is more real than the cities you are not in. Paris does not blink out of existence because you are in Tokyo. It is simply elsewhere, at a different location in space. The Eternalist asks you to extend this same intuition to time. The year you were born does not blink out of existence because you are no longer there. It is simply elsewhere, at a different location in time. Your distance from it is temporal rather than spatial, but the Eternalist insists that this distinction does not affect its reality. Distant in time, like distant in space, still means real. This runs against everything intuition tells us, and it is important not to brush that intuition aside too quickly. The feeling that the past is gone is one of the most powerful and universal human experiences. We mourn the dead precisely because they seem to no longer exist. We feel regret because what is done cannot be undone, which seems to mean that the moment of the deed has slipped beyond reach into non-existence. The Eternalist is not denying these feelings. They are denying the interpretation we naturally place on them. The past is beyond reach, yes, but beyond reach is not the same as non-existent. A locked room you cannot enter still contains its furniture. The Eternalist claims that the past is a region you cannot return to, not a region that has ceased to be. To see why a serious physicist would entertain such a strange idea, we need to understand that it did not arise from idle philosophizing. It emerged from a specific and unavoidable consequence of how the universe actually behaves, a consequence discovered at the start of the 20th century, when Einstein overturned the foundations of physics. Before Einstein, time was understood in the way Isaac Newton had described it. Newton imagined time as absolute and universal, a single cosmic clock, ticking at the same rate everywhere in the universe. According to this view, there was a single objective present moment, a now that swept across the entire cosmos simultaneously. If it was this instant here, it was this same instant on the far side of the galaxy and on the most distant star. The universe shared one common heartbeat, and the question of what was happening right now, anywhere in existence, had a definite, unambiguous answer. This picture feels correct. It matches our experience so well that for 2 centuries it was simply assumed to be how reality worked. But it turned out to be false. The universal now, the shared cosmic instant, does not exist. And the discovery that it does not exist is what cracked open the door to the block universe. The reasoning runs through the nature of light, the behavior of moving observers, and a set of conclusions so precise that they have been confirmed in laboratories countless times. The strange thing about the present, it turns out, is not that it flows. The strange thing is that there is no single present at all. Different observers, moving differently, will disagree about which events are happening at the same time, and there is no fact of the matter that settles the dispute between them. That last claim deserves careful attention, because it is the hinge on which the entire argument turns. If there is no universal present, if the now genuinely fractures into different versions for different observers, then the comfortable idea of a single advancing moment, the same for everyone, collapses. And once it collapses, we are forced to ask what remains. What kind of reality could accommodate many disagreeing presents at once, with no way to choose between them? The answer that physics seems to push us toward is the block, a structure spread out in time, where the question which moment is really now has no more objective answer than the question which city is really here. But to see exactly how relativity forces this conclusion, we have to look closely at what happens to time itself when things begin to move. The trouble begins with a single fact about light, a fact so unexpected that it forced a complete rebuilding of our understanding of time. The speed of light in empty space is constant. No matter who measures it, no matter how that person is moving, the answer always comes out the same. This sounds harmless until you examine what it actually implies, because it violates everything. Common sense tells us about how speeds add together. Think about how velocities normally combine. If you are on a train moving at 100 kilometers per hour, and you walk toward the front of the train at 5 kilometers per hour, then someone standing beside the tracks sees you moving at 105. Your speed and the train's speed simply add. This is the ordinary arithmetic of motion, and it works perfectly for trains, cars, thrown balls, and everything else in daily life. Now replace yourself with a beam of light. Shine a flashlight toward the front of the train. You might expect the person beside the tracks to measure the light moving at the speed of light plus the speed of the train, but they do not. They measure the light moving at exactly the speed of light, the same value you measure aboard the train. The train's motion adds nothing. The light refuses to go faster. This is not a measurement error or a quirk of flashlights. It is a deep feature of the universe, confirmed in experiment after experiment with extraordinary precision. And it leaves us with a genuine paradox, because something has to give. If the speed of light is the same for everyone regardless of their motion, then our ordinary assumptions about space and time cannot all be correct. Speed is distance divided by time. If everyone agrees on the speed of light, but they are moving differently relative to one another, then they cannot all agree on distances and times. Something about space, or time, or both, must be flexible. Einstein's revolutionary step was to accept this fully. He kept the constancy of light as a fixed principle and let space and time bend around it. What bent, it turned out, was the very notion of simultaneity, the idea that two events can be said to happen at the same time. Here is how the breakdown occurs. Imagine a train car, and imagine a passenger standing exactly in the middle of it. At the precise center, a lamp flashes once, sending light in both directions, toward the front of the car and toward the back. The passenger in the middle sees the light reach the front wall and the back wall at the same instant. This makes sense. The light travels equal distances in equal times, so it arrives at both ends together. For the passenger, the two events, light hitting the front and light hitting the back, are simultaneous. They happen at the same moment. Now consider someone standing on the platform as the train rushes past. This observer watches the same flash, the same light spreading toward both ends of the car. But from the platform, the situation looks different. During the time the light is traveling, the train is moving forward. The back wall of the car is rushing toward the point where the flash occurred, while the front wall is racing away from it. The light heading backward therefore has less distance to cover, because the back wall is coming to meet it. The light heading forward has farther to go, because the front wall is fleeing from it. Since the light moves at the same speed in both directions, as it must, it reaches the back wall first and the front wall second. For the platform observer, the two events are not simultaneous. The back is struck before the front. Stop and absorb what has just happened. We have two observers, the passenger and the platform watcher, looking at the same pair of events. One says they happened at the same time. The other says they happened at different times, with a definite order, back first. And neither of them is wrong. There is no experiment either could perform to prove the other mistaken. The passenger's frame of reference is as valid as the platform's. Simultaneity, the question of whether two distant events happen at the same moment, has no single answer. It depends on the motion of whoever is asking. This is the relativity of simultaneity, and it is one of the most thoroughly confirmed results in all of physics. The consequence for our idea of the present is direct and severe. The present moment, the now, is nothing other than the set of all events happening simultaneously with this instant. When you say something is happening right now on a distant planet, you are making a claim about simultaneity across a vast distance. But if simultaneity itself depends on motion, then so does the present. Your now and my now can contain different events. There is no shared, universal slice of the cosmos that everyone agrees is happening at this moment. The single advancing present that Newton assumed, the cosmic heartbeat ticking everywhere at once, simply does not exist. It has been replaced by a multitude of presents, each tied to a particular state of motion, none privileged above the rest. This is the result that drives us toward the block universe. Consider what it means carefully. Suppose you are standing still, and I walk past you. Because we are moving differently, our planes of simultaneity, the slices of events we each call now, are tilted differently through the structure of reality. My now includes a certain set of distant events. Your now includes a slightly different set. For an event far enough away, my present might include something that, for you, still lies in the future, or has already slipped into the past. And here is the crucial point. If that event is real and present for me, And if my frame is just as valid as yours, then the event must be real, even though for you it has not yet happened. The future event, from your perspective, must already exist, because it exists in someone else's legitimate present. Philosophers have sharpened this argument into a formal chain of reasoning, sometimes called the Reitdijk-Putnam argument, after the thinkers who developed it. The logic runs as follows. What is real and present for one observer must be real, full stop, because reality cannot depend on who is looking. Relativity shows that observers in different states of motion have different presence. Therefore, events that lie in the future for one observer are present, and hence real for another. And if those future events are real, then the future, at least in part, already exists. The same reasoning applies to the past. Stretch this across all possible observers and all possible events, and the conclusion is that all events, past, present, and future, share equal reality. The block universe falls out of the physics almost inevitably, not as a wild speculation, but as the natural reading of what relativity tells us about time. It is worth being honest about the strength of this argument. It is not a proof in the strict mathematical sense, because it relies on a philosophical premise, the idea that what is present for any valid observer must count as real. A determined opponent could reject that premise, but the premise is difficult to abandon, because the alternative is to say that reality itself plays favorites among observers, granting full existence to the events in one person's present and denying it to the events in another's, even though physics treats all of them as equally legitimate. That kind of favoritism has no basis in the equations. The equations do not single out any frame as the true one. They treat all uniform motion as equivalent, a principle so central that it gives relativity its name. To insist on a single privileged present is to add something to the physics that the physics itself does not contain. So the picture that emerges is this: the motion of an observer tilts their slice of the present. And because different observers slice the universe at different angles, the totality of what any observer might call now sweeps across an enormous range of events. To accommodate all these overlapping, disagreeing presents within a single coherent reality, the events they refer to must all exist together. The universe must be extended in time, laid out as a four-dimensional whole, with the flowing now reduced to a feature of individual perspectives rather than a property of the cosmos. But this raises an immediate and pressing question. If a small difference in motion tilts the present only slightly, how large can the effect become? Could ordinary, everyday motion, the kind we engage in without a second thought, actually shift our slice of reality far enough to reach across truly cosmic distances? The answer, as we are about to see, is stranger than the train example alone would suggest, and it carries the disagreement about the present out to the scale of entire galaxies. The tilt in the plane of simultaneity might seem like a negligible effect, something that matters only for objects moving at speeds approaching that of light. On the train, the disagreement between passenger and platform amounts to a fraction of time so small that no human could ever notice it. The events at the front and back of the car are separated by mere meters, and the resulting discrepancy in their timing is buried far below the threshold of perception. It would be tempting to conclude that while the relativity of simultaneity is real, it is also practically irrelevant, a curiosity confined to the world of fast-moving particles and precision instruments. But this conclusion overlooks a crucial factor, and that factor is distance. The amount by which two observers disagree about the timing of a distant event depends on two things. One is their relative speed. The other is how far away the event is. The tilt of the simultaneity plane is small for slow speeds, but its effect grows in proportion to distance. A slight tilt produces a tiny displacement nearby, but the same tilt, extended across an immense gulf of space, produces an enormous displacement at the far end. Picture a long, rigid beam balanced at its center. If you tip one end down by a hair, the nearby portion of the beam barely moves, but a point far out along its length swings through a large arc. The geometry is the same with planes of simultaneity. A nearly imperceptible difference in motion, applied across the vast distances of the cosmos, can shift the boundary between past and future by a startling amount. This is the heart of a thought experiment known as the Andromeda paradox, formulated by the mathematician and physicist Roger Penrose. The Andromeda galaxy is the nearest large spiral galaxy to our own, lying roughly 2.5 million light-years away. It is so distant that the light reaching our telescopes tonight left it before modern humans existed. Penrose used this remote galaxy to expose just how dramatically the relativity of simultaneity can reshape the present, and the result is genuinely difficult to reconcile with intuition. Imagine two people standing on a sidewalk, side by side. One of them is standing still. The other is walking at an ordinary, leisurely pace, perhaps a few kilometers per hour, the speed of a casual stroll. They are at the same place at the same moment. By every ordinary measure, they share the same now. Yet because one is walking and the other is stationary, their planes of simultaneity are tilted very slightly relative to one another. Near the sidewalk, this tilt makes no observable difference. But extend the planes out to the Andromeda galaxy, 2.5 million light-years away, and the tiny tilt has grown into a gap of days. The two pedestrians standing in the same spot have presents that, at the distance of Andromeda, differ by several days. Now make the example concrete in the way Penrose did. Suppose that in the Andromeda galaxy, some momentous event is unfolding. Penrose imagined a fleet departing on a journey toward Earth, but the nature of the event is unimportant. What matters is its timing. For the person standing still, the fleet has not yet launched. Its departure lies in their future, an event still to come, not yet decided, not yet real in the ordinary sense. For the person walking in the direction of Andromeda, the fleet has already departed. Its launch lies in their past, a settled fact, an event that has already happened. Two people, standing on the same sidewalk at the same instant, disagree about whether a particular event in the distant galaxy has occurred. For one, it is still in the undetermined future. For the other, it is already history. The unsettling part is the ordinariness of the motion involved. We are not talking about spaceships traveling near the speed of light. We are talking about walking. A person ambling down the street at a few kilometers per hour, simply by virtue of that gentle motion, shifts their plane of simultaneity across the cosmos by enough to move an event days into the past or future at the distance of Andromeda. And the direction matters. Walking toward Andromeda moves its events into your past. Walking away from it moves the same events into your future. Turn around, and the present at Andromeda jumps by several days in the opposite direction. The slice of the universe you call now is not fixed. It pivots with your every change of pace and direction, swinging across millions of years of cosmic distance in response to motions so small, you do not even register them. Penrose drew the conclusion plainly. If the event in Andromeda is already determined and real for the walking person, and if that person is doing nothing more exotic than walking, then the event must be determined and real in some absolute sense. There is no coherent way to say that the fleet's departure is real for the walker, but unreal for the stationary observer, when the only difference between them is a stroll. Both are equally valid observers. Both have equally legitimate frames of reference. If reality is to be consistent, the event must simply be real, regardless of who is walking and who is standing. And if a future event can be real in this way, then the future, in some meaningful sense, already exists. This is precisely the conclusion of the block universe, now arrived at not through abstract argument, but through a vivid and almost absurdly mundane scenario. There is a subtlety here that is often misunderstood, and it deserves clarification because the Andromeda paradox is sometimes overstated. The disagreement between the two pedestrians does not allow either of them to know what is happening in Andromeda right now. No information has traveled faster than light. The walker cannot look up and see the fleet departing, and the stationary person cannot see that it has not. The light from those events will not arrive for 2.5 million years, regardless of how anyone walks. The paradox is not about observation or knowledge. It is about reality, about what exists. The two observers cannot detect the difference in their presence, but the difference is real all the same, written into the geometry of space-time. The argument does not say we can see the future. It says the future already exists, even though it remains hidden behind the cosmic distance that light must cross to reach us. This distinction matters because it blocks a tempting escape route. One might hope to dismiss the whole thing by saying that since the disagreement can never be observed, it does not really mean anything. But this misunderstands the nature of the claim. Physics is full of features that cannot be directly observed, yet are taken to be real because they are required for the consistency of the theory. The relativity of simultaneity is one of these. It is not an optional interpretation that we can take or leave. It is a structural feature of the space-time that relativity describes, the same space-time that gives us the correct predictions for everything, from the lifetimes of fast-moving particles to the precise functioning of global positioning satellites. To accept the physics is to accept the geometry, and the geometry contains the tilting planes of simultaneity, whether we can observe their consequences in Andromeda or not. What the Andromeda paradox really demonstrates is that the present is not a thing the universe possesses. It is a thing observers carry with them, and different observers carry different ones. There is no master slice, no privileged now that the cosmos as a whole agrees upon. Each observer's present is a particular cut through the four-dimensional structure of events, and the angle of that cut depends on motion. Slow motion, fast motion, it does not matter in principle, only in degree. Even the gentlest stroll tilts the cut. And once we accept that the present is merely one cut among countless equally valid alternatives, the idea that this cut is uniquely real, that only the events it contains exist while all others wait in non-existence, becomes very hard to defend. The events on every possible cut must be real, because every cut belongs to some legitimate observer, and reality cannot be parceled out according to who happens to be walking which way. So we are led, step by careful step, to a vision of the universe in which all of time is laid out at once, every event fixed in its place, the flowing present dissolved into a multitude of perspectives. But to truly grasp what this means, we need a way to picture it, a mental model of a universe where past, present, and future coexist. The flat planes and tilting cuts are useful, but they are abstract. What would it actually look like to hold the whole of space-time in view? To see the structure within which every moment of every life is permanently embedded? For that, we need an image that physicists have found surprisingly useful. An image drawn not from the heavens, but from something far more ordinary. The image physicists often reach for is a loaf of bread. It is an unglamorous comparison for so profound an idea, but it captures the essential geometry with remarkable clarity. And once you have it in mind, the structure of the block universe becomes much easier to hold steady. Picture a long loaf, the kind you might slice for sandwiches. The loaf as a whole represents the entirety of space-time, all of existence across all of time, taken as a single four-dimensional object. Now imagine cutting it into slices. Each slice is a moment, a present, a three-dimensional snapshot of the entire universe at one instant. The loaf is not made of moments stacked up and being consumed one at a time. The loaf is whole. All the slices are already there, pressed together, each one a complete cross-section of reality at a particular time. This is where the picture earns its usefulness. When you take an ordinary loaf and cut straight down, perpendicular to its length, you get the familiar slices. But you could also cut at an angle, tilting the knife, and you would get a different set of slices, each containing a slightly different combination of bread. The relativity of simultaneity is exactly this. Different observers slice the loaf of space-time at different angles. An observer at rest cuts straight across. An observer in motion cuts at a tilt. Each slice is that observer's present, their now, the set of events they regard as simultaneous. And just as the angled cut through the bread captures different crumbs than the straight cut, the tilted slice through space-time captures different events as present. The loaf itself does not change. Only the angle of cutting changes, and with it, the contents of each observer's now. This model, sometimes called the block universe loaf, or simply the loaf of space-time, makes vivid what the Andromeda paradox demonstrated. The walking pedestrian and the stationary one are slicing the same loaf at slightly different angles. Near themselves, the slices nearly coincide, which is why they agree about local events. But far out along the loaf, at the position of Andromeda, the tilt has separated the slices considerably, which is why they disagree about whether the distant fleet has departed. The disagreement is not a contradiction. It is simply the geometry of two different cuts through one unchanging object. Both slices are equally valid ways of carving up the same reality, and the events each contains are equally real, because they all belong to the same loaf. Hold on to this image, because it forces a particular way of thinking about existence. In the loaf model, nothing is being created, and nothing is being destroyed. The slices are not appearing one after another, lighting up briefly and then going dark. They are all simply present, all parts of the one object. The future slices are no less substantial than the past ones. They are merely located toward one end of the loaf rather than the other. To ask which slice is the real present is, in this picture, like asking which slice of an actual loaf is the real slice. There is no such thing. Each slice is real, and which one counts as now depends entirely on where you happen to be positioned and how you happen to be moving. The now is a local fact about an observer, not a global fact about the loaf. This is profoundly different from the way we ordinarily experience time, and the difference is worth dwelling on. In ordinary experience, the present feels like the only thing that exists. The past feels gone, vanished, retained only as memory. The future feels open, unmade, not yet real. We live as though reality were a single moving slice, a spotlight sweeping along the loaf, illuminating one cross-section at a time, while everything before and after sits in darkness. The block universe says this spotlight does not exist, or rather, it exists only as a feature of our experience, not as a feature of the loaf itself. The loaf is uniformly real along its entire length. There is no traveling spotlight in the physics, no moving point of illumination that the equations track or require. The sense of a moving now is added by the observer, painted onto a structure that, in itself, simply sits there, complete and timeless. Consider what this implies for the events of your own life. Your birth is a slice near one end of a particular region of the loaf. Your death is a slice some distance further along. Every moment in between, every breath, every thought, every ordinary afternoon, occupies its own thin slice, fixed permanently in place. From the perspective of the loaf as a whole, you are not a thing that moves through time. You are a shape extended through it, a long, intricate ribbon stretching from your first moment to your last, every part of that ribbon equally present. The philosopher's term for this is a world line, the complete four-dimensional path of an object through space-time. Your world line is already there in its entirety, from beginning to end. The feeling that you are traveling along it, that you are currently at one particular point, with the rest still to come, is the feeling the block universe asks us to reinterpret. It is natural to resist this, and the resistance usually takes a specific form. Surely one wants to object, there is something special about this moment, the one I am experiencing right now. It does not feel like just another slice indistinguishable from the rest. It feels uniquely vivid, uniquely real, lit up in a way that yesterday is not. But the block universe has an answer to this, and it is a subtle one. Every slice contains observers, and every one of those observers feels exactly the same way about their own slice. The version of you reading this sentence feels that this moment is the real one, but the version of you that ate breakfast this morning felt at that time that breakfast was the real moment, the vivid present. And the version of you that will go to sleep tonight will feel that going to sleep is the present. Each slice carries its own conviction of being the now. None of them is privileged. The feeling of being present is universal across all the slices, which means it cannot be used to single out any one of them as the true present. The vividness is a feature of conscious experience wherever it occurs along the loaf, not a property that marks one slice as more real than the others. This points to a deep and recurring theme in the Eternalist picture. Many of the features we attribute to time itself turn out, on closer inspection, to be features of our experience of time. The flow, the passage, the special status of the present, the gone-ness of the past, the openness of the future. Each of these can be understood as something the mind contributes, rather than something the universe contains. The loaf does not flow. The loaf does not have a present. The loaf does not lose its past slices or wait for its future ones. All of that activity All of that becoming happens in the experience of observers embedded within the loaf. Observers who carry their vivid sense of now with them at every point along their world line. The universe is static and complete. The dynamism is in us. If this is right, it reframes a great many things, but it also sharpens a problem that we have so far set aside. If the loaf is static, if there is no real flow and no privileged present, then why do we experience time the way we do? Why does it seem so overwhelmingly that time moves, that moments pass, that we are carried from past to future and never the reverse? An illusion this powerful, this universal, this consistent, demands an explanation. It is not enough for the Eternalists to say that the flow of time is in our minds. They must account for why our minds produce this particular illusion, and why it always points in the same direction, from past to future, and never back. A static loaf has no built-in direction. Its slices are simply arranged in order. So where does the arrow come from, the relentless one-way character of our experience? That question turns out to lead somewhere unexpected, into the physics of heat, disorder, and the gradual unwinding of the cosmos itself. The puzzle is sometimes called the arrow of time, and it is sharper than it first appears. In the block universe, the loaf has a temporal extent, a length along the time axis. But length alone does not imply direction. A ruler is long, but it has no built-in sense of which end is the beginning. The slices of space-time are arranged in a sequence, but a sequence can be read either way, from one end to the other, or from the other end back. Nothing in the geometry of the loaf says that one direction along the time axis is forward and the other backward. And yet our experience is utterly lopsided. We remember the past and not the future. We see causes precede effects, never the reverse. We grow older, never younger. Time, in our experience, has a direction as definite as down is for gravity. If the underlying reality is a directionless block, where does this powerful one-way arrow come from? The deepest part of the puzzle is that the fundamental laws of physics do not contain an arrow of time. This is one of the most surprising facts in all of science, and it is worth stating carefully. The equations that govern the motion of particles, the behavior of forces, the interactions of matter and energy are very nearly symmetric in time. If you took a recording of any fundamental physical process and ran it backward, the reversed process would also obey the laws of physics. A planet orbiting a star, run in reverse, is just a planet orbiting the other way, equally valid. Two particles colliding and bouncing apart, run in reverse, is just two particles approaching and colliding, equally valid. At the level of the basic equations, the universe does not distinguish forward from backward. The laws work the same in both directions. So the arrow we experience cannot come directly from the fundamental laws, because those laws have no arrow to give. And yet, the world is manifestly not symmetric in time. We never see a shattered cup gather itself together and leap back onto the table whole. We never see smoke flow back into a fire and reconstitute the wood. We never see a cold cup of coffee spontaneously grow hot while the room around it cools. These reversed processes are not forbidden by the fundamental laws. Each individual particle in the shattered cup could, in principle, move in exactly the way required to reassemble it. The laws permit it, yet it never happens. There is a glaring contradiction here between the time symmetry of the deep laws and the blatant time asymmetry of the world we live in. Resolving this contradiction is where the arrow of time is finally found, and the resolution lies in a single powerful concept, the concept of entropy. Entropy is roughly a measure of disorder, but it is more precise to think of it as a measure of how many different microscopic arrangements correspond to the same overall appearance. Consider a deck of cards, fresh from the box, sorted by suit and rank. There is exactly one arrangement that counts as perfectly ordered in this way. Now, shuffle the deck. There are an astronomical number of shuffled arrangements, and almost all of them look disordered, random, with no discernible pattern. If you shuffle a sorted deck, it becomes disordered, not because disorder is a force pulling on the cards, but simply because there are vastly more disordered arrangements than ordered ones. The deck wanders into a disordered state because disordered states are overwhelmingly more common. To shuffle back into perfect order would require hitting one specific arrangement out of the countless possibilities, which essentially never happens by chance. This is the key to the arrow of time. The second law of thermodynamics states that the entropy of an isolated system tends to increase over time. Order tends to give way to disorder, not because of any fundamental directional law, but because of overwhelming probability. There are so many more ways to be disordered than ordered that any system left to itself drifts toward disorder simply by the blind statistics of its possibilities. The cup shatters rather than reassembles because there are countless arrangements of cup fragments and only one arrangement of intact cup. The coffee cools rather than spontaneously heats because there are countless ways for its heat energy to spread into the room and almost no way for it to concentrate back. Every familiar irreversibility, every process that runs one way and never the other, is at bottom a statement about probability, about systems moving from less probable ordered states to more probable disordered ones. So the arrow of time, the directionality we experience, is the arrow of entropy. The past is the direction in which entropy was lower. The future is the direction in which entropy is higher. We do not remember the future because memory itself is a physical process that depends on entropy increasing. Forming a memory means creating an ordered record, and creating that record requires expelling disorder into the surroundings, which only happens in the direction of increasing total entropy. The asymmetry between a known past and an open future, the asymmetry between cause and effect, the asymmetry between aging and growing young, all of these trace back to the same statistical tendency, the relentless drift from order to disorder that characterizes the universe at large. But notice what this resolution does and does not provide. It explains why there is an arrow, a direction, but it does not reintroduce any flow. Entropy increases along the time axis, which gives the axis a direction, the way a sequence of numbers increasing from one end to the other gives that sequence a direction. But this is a static fact about the loaf, not a dynamic process happening to it. In the block universe, the entropy of each slice is simply what it is, fixed and unchanging. The slices toward one end have lower entropy, the slices toward the other have higher entropy, and that gradient defines which direction we call forward. The loaf does not need to flow for this to be true. The gradient is just there, a feature of how the slices are arranged. The arrow of time, properly understood, is not the loaf moving in a direction. It is the loaf having a direction, a built-in asymmetry between its two ends, like the difference between the head and foot of a long, still object. This raises a profound further question, one that pushes the inquiry into cosmology. If entropy always increases toward the future, then it was lower in the past. And if we follow that backward, slice by slice, we arrive at a beginning where entropy was extraordinarily low, far lower than anything we see today. The early universe, near the moment of the Big Bang, must have been in a state of remarkably high order, an extremely improbable state for the entire subsequent history of increasing entropy to follow from it. This is sometimes called the past hypothesis, the assumption that the universe began in a very low entropy condition. Why it did so remains one of the great unsolved questions in physics. There is no agreed explanation for why the cosmos started in such an ordered state, rather than in the far more probable disordered one. But whatever the reason, that low entropy beginning is the ultimate source of the arrow of time. Every irreversibility we observe, every memory we form, every aging process, every shattered cup, traces back to the improbable orderliness with which existence began. What we have, then, is a striking reconciliation. The fundamental laws are time-symmetric, with no arrow. The block universe is static, with no flow. And yet the world we experience has a powerful, consistent direction to it. The bridge between these is entropy, a statistical asymmetry imposed not by the laws, but by the initial conditions of the cosmos. The arrow is real, in the sense that it is a genuine feature of how matter is arranged across the slices of the loaf. But it is not the flow of time. It is a gradient within a static structure, a difference between the two ends of an unchanging object. The loaf does not move. The loaf is merely lopsided, ordered at one end and disordered at the other. And we, embedded within it, interpret that lopsidedness as the passage of time. This still leaves something unaccounted for, and it may be the most personal part of the entire puzzle. We have explained why there is a direction to time, why the past differs from the future, why entropy gives the loaf its asymmetry. But we have not explained the feeling of passage itself, the vivid sense that moments are actively flowing past, that we are being carried along, that the present is in continuous motion. The entropy gradient explains the arrow, but it does not obviously explain the experience of movement. A lopsided loaf is still a static loaf. So why does it feel so insistently like we are moving through it? To answer that, we have to turn from the physics of the cosmos to the workings of the mind, and ask how a brain embedded in a static structure could manufacture the overwhelming impression of a flowing now. If the universe is a static loaf, and if the arrow of time is merely an entropy gradient within that loaf, then the sensation of time flowing must be something the brain produces, rather than something the brain detects. This is a strong claim, and it deserves to be examined with the same care as the physics. The Eternalist is asserting that one of the most immediate and undeniable features of human experience, the felt passage of time, does not correspond to anything actually passing in the external world. It is a construction assembled by the nervous system, a kind of useful interpretation rather than a direct perception of reality. To make this plausible, we need to understand how the brain handles time and what it is actually doing when it generates the feeling that the present moment is sliding forward. Begin with a basic observation about perception. The brain does not have direct access to the world. It has access only to signals, electrical and chemical, arriving from the senses. Everything you experience as the immediate present is in fact a construction assembled from these signals, a model the brain builds and continuously updates. And this model is not assembled instantaneously. It takes time for light to reach your eyes, for the signals to travel along your optic nerves, for your visual cortex to process them into recognizable shapes. By the time you consciously see something, the event you are seeing is already in the past, by a fraction of a second. The present you experience is not the true present of the external world. It is a slightly delayed reconstruction, stitched together from information that has already aged on its way to your awareness. This delay alone shows that the experienced now is a fabrication of sorts, a processed image rather than raw contact with reality. But the construction goes much deeper than a simple delay. The brain integrates information from different senses that arrive at different speeds. Sound travels far slower than light, and neural signals from different parts of the body take different amounts of time to reach the brain. If you touch your nose and your toe at the same instant, the signal from your nose arrives well before the signal from your toe. Yet you experience the two touches as simultaneous. The brain compensates, adjusting and aligning signals to produce a coherent sense of a single, unified moment. The now you experience is not a given. It is the output of an elaborate process of synchronization, a constructed simultaneity that papers over the staggered arrival of the underlying data. Now consider how the brain handles the relationship between moments. To function in the world, an organism must connect what just happened to what is happening now and anticipate what will happen next. The brain maintains a running model that includes a representation of the immediate past, held in short-term memory, and a set of predictions about the immediate future. It is constantly comparing incoming signals against its predictions, updating its model as new information arrives. This continuous process of retaining the just past, registering the present, and anticipating the about to be, may be the very source of the feeling of flow. The sense that time is moving could be nothing more than the brain's experience of its own updating, the felt quality of a model that is perpetually revising itself as fresh signals arrive and old ones recede into memory. Think about what it would be like for such a system from the inside. At each moment along its world line, the brain holds a snapshot that includes traces of earlier moments in the form of memory and projections of later ones in the form of expectation. From within any given slice, the brain has access to records of the slices behind it, but not the slices ahead. This asymmetry, built on the entropy gradient that allows memories to form in the first place, gives every moment a sense of coming after the remembered past and before the anticipated future. String these moments together, each one containing its own memories of what came before, and you generate an experience that feels exactly like motion through time, even though nothing is actually moving. Each slice simply contains, as part of its static contents, the impression of having arrived from the previous one. The flow is not a process happening across slices. It is a quality present within each slice, the quality of seeming to have just moved. An analogy may help, though it must be handled carefully. Consider the individual frames of a film. Each frame is a still image, frozen and motionless. Nothing in any single frame moves. Yet when the frames are arranged in sequence, and a consciousness takes them in, the impression of smooth motion emerges. The motion is not in any frame. It is in the relationship between frames as experienced. But the block universe pushes the analogy one step further, and in a stranger direction. In an ordinary film, the frames really are projected one after another, So there is a genuine sequence in time. In the block universe, there is no projector, no sequential lighting up of frames. All the frames simply exist together. The impression of motion does not even require them to be played in order, because each frame, each slice, already contains within itself the memory traces and anticipations that constitute the feeling of flow. The motion is generated frame by frame, locally within each static slice, by the brain that slice contains. This is a difficult idea, and it is worth being honest about how counterintuitive it is. It asks us to accept that the version of you in each moment is, in a sense, complete in itself, a static configuration that includes the full experience of that moment, with all its felt sense of flow already built in. There is no traveling self that moves from slice to slice, carrying consciousness along. Instead, there are many momentary selves, one in each slice, each fully experiencing its own present, each equipped with memories of earlier selves and expectations of later ones. The continuity you feel, the sense of being a single self persisting through time, is woven from the memory connections between these momentary selves. Each one remembers the previous, which creates the impression of an unbroken thread. But the thread is a relationship among static parts, not a single object sliding along the loaf. Some have compared this to the way we understand the continuity of a melody. A melody seems to be a single flowing thing, but it is in fact a sequence of distinct notes. The flow of the melody exists in the way each note is heard against the memory of the notes before it. The melody as a whole is not present in any single instant, yet we experience it as a unified, moving line. The self in the block universe is something like this. It is not present in any single slice in its entirety. It is a pattern distributed across many slices, experienced as continuous because each slice contains the echoes of the others. The feeling of being carried forward is the feeling of each momentary self registering its connection to the ones behind it. If this account is correct, then the flow of time joins the lengthening list of things that turn out to belong to the observer rather than the world. The present, we saw, is a feature of an observer's frame of reference, not a global fact about the cosmos. The arrow of time is a feature of the entropy gradient, a static asymmetry rather than a moving process. And now, the flow itself, the felt passage, becomes a feature of how a memory-equipped, prediction-making brain experiences its own embedding in the loaf. At every turn, the dynamism we attribute to time gets relocated from the universe into the mind. The loaf remains still. The activity is all in the experiencing. This relocation has consequences that reach beyond physics and psychology into questions about ourselves that we cannot easily set aside. If the future already exists, fixed and real, as solidly as the past, then in what sense is anything we do undetermined? When you face a decision, weighing your options, deliberating about what to do, the block universe seems to say that the outcome is already there, already part of the loaf, already a settled fact at the coordinates of your future. The deliberation feels open. The choice feels free. But if the slice containing your decision already exists, fully formed, then was the outcome ever really in doubt? This is perhaps the most unsettling implication of the entire picture, and it forces us to confront what freedom could possibly mean in a universe where every moment, including every choice we will ever make, is permanently and equally real. The challenge to free will seem at first to be devastating. If the block universe is real, then the future is not a realm of open possibilities waiting to be settled by our choices. It is a region of space-time that already exists, as fixed and definite as the past. The slice containing tomorrow's decision is already there in the loaf, with the decision already made, the outcome already determined. When you sit deliberating over a choice, agonizing between options, the block universe appears to say that your deliberation is a kind of performance, a process unfolding toward a conclusion that was never actually in question, because that conclusion is already written into the structure of reality at the coordinates where it sits. The feeling of an open future, of genuinely being able to go one way or the other, would be as much an illusion as the flow of time itself. This is a serious worry, and it would be dishonest to wave it away. But it is worth examining closely, because the relationship between the block universe and free will is more subtle than the initial impression suggests, and a good deal of the apparent threat dissolves under careful analysis. The first thing to notice is that the block universe is a claim about the existence of events, not about how those events are brought about. Saying that the future already exists is not the same as saying that the future is imposed from outside, independent of your choices. The slice containing your decision exists, yes, but what that slice contains is precisely you, making the decision through your own process of deliberation. Your choosing is not bypassed by the block. Your choosing is part of the block. The decision is in the loaf, but it is in the loaf because you make it, not in spite of your making it. To see why this matters, consider the difference between two ways the future might be fixed. In one version, fatalism, the outcome is settled regardless of what you do. No matter how you deliberate, no matter what you decide, the same thing happens. Your choices are irrelevant, mere theater, with no effect on the result. This is genuinely incompatible with any meaningful freedom, but it is not what the block universe claims. In the block universe, your choices are entirely relevant. They are the very things that determine what the future slices contain. The future is fixed, but it is fixed in part by your decisions, which are themselves real events in the loaf, doing real causal work. Remove your deliberation, and the future would be different. The outcome depends on your choice, even though both the choice and the outcome already exist. This is a completely different situation from fatalism, where the outcome would be the same no matter what you chose. The confusion arises from a hidden assumption smuggled into the worry, the assumption that if something already exists, then it must have been forced, compelled, made inevitable by something other than the agent. But existence and compulsion are different things. The past already exists too, in the block universe. And yet we do not think the past was compelled in any troubling sense. The choices you made yesterday are fixed now, settled, unchangeable. But they were still your choices, made freely by your own lights at the time, for your own reasons. Their being fixed now after the fact does not retroactively make them unfree. The block universe simply extends this same situation to the future. The future is fixed in the way the past is fixed. But just as the fixity of the past does not undermine the freedom of past choices, the fixity of the future need not undermine the freedom of future ones. The future slices are settled, but they are settled by what the agents in them do. There is a deeper point here about what we actually want when we want free will. The intuition that drives the worry is that for a choice to be free, the future must be genuinely open, with multiple possibilities really available. and the choice must select among them. But there is a long philosophical tradition called compatibilism, which argues that this is not what freedom requires at all. On this view, what makes an action free is not that it could have gone otherwise in some absolute metaphysical sense, but that it flows from the agent's own desires, reasons, and deliberations without external coercion. A free choice is one that is caused in the right way, by the agent's own reasoning process, rather than being forced by something outside the agent. If your decision results from your own weighing of reasons, your own values, your own thinking, then it is free in the sense that matters, regardless of whether the universe is a block or not. The fixity of the outcome does not threaten this kind of freedom, because the outcome is fixed by your reasoning, which is exactly what we want freedom to consist in. It is true that compatibilism does not satisfy everyone. Some insist that real freedom requires a future that is open in the strongest possible sense, with genuinely undetermined outcomes that the agent settles through choice. For those who hold this view, the block universe does present a real challenge, because the block contains a definite future, regardless of the apparent openness of our deliberations. But it is important to recognize that this challenge is not unique to the block universe. It arises from determinism in general, the idea that the present state of the world, together with the laws of physics, fixes the future. Any deterministic physics raises the same question about free will, block universe or not. The block universe does not add a new threat. It simply makes the existing one vivid by laying the future out as an existing structure, rather than describing it as a consequence yet to be computed. The philosophical problem of freedom and determinism is old, and it stands or falls on grounds quite separate from the geometry of space-time. And here, a genuine subtlety enters, because it is not actually settled that the universe is deterministic. The block universe of relativity describes a four-dimensional structure in which events are laid out. But relativity by itself does not tell us whether the contents of the future slices are uniquely determined by the past ones. That is a separate question, and it is precisely the question on which the other great theory of modern physics, quantum mechanics, seems to disagree. In quantum mechanics, the outcomes of certain events appear to be genuinely probabilistic, not fixed in advance by anything in the prior state of the world. If that appearance reflects reality, then the future is not determined by the past, and the block universe, if it exists at all, contains a future that was not computable from its earlier slices. This complicates the picture considerably, and it is one of the reasons the block universe remains a matter of interpretation rather than settled fact. But set the quantum question aside for a moment, because there is something worth appreciating in the block universe view of choice, even on its own terms. The picture it offers is not one of helpless passivity. You are not a passenger being dragged through predetermined events by a force outside yourself. You are an active part of the structure, and your deliberations, your efforts, your decisions are woven into the loaf as real and effective. The shape of your future depends on them. The fact that the result already exists does not mean you are not the author of it. In a sense, the block universe makes you permanently the author. The choices you make are not erased by time passing. They remain forever real, fixed in the loaf, eternal features of the structure of reality. Your decision today is not a fleeting event that vanishes the moment it is made. It is a permanent part of the universe, as enduring as anything else in the loaf. Still, the worry has a residue that careful philosophy does not entirely remove, and honesty requires acknowledging it. There is something about the felt experience of deliberating, the sense of the future being genuinely open as we stand at the threshold of a choice, that sits uneasily with the picture of a future that already exists. We may be able to argue convincingly that the fixity of the future does not undermine freedom in any sense we should care about. But the feeling of openness remains, and it is at least worth wondering whether that feeling, like the feeling of flow, is another construction of the mind, a useful interpretation that does not correspond to the underlying structure. Perhaps the openness of the future is something the deliberating brain experiences from the inside, even though the future it deliberates about is, viewed from outside the loaf, already there. If so, then free will joins flow and the present as features of experience, rather than features of the world, and the block remains untroubled by our sense of choosing. Whether the future is truly fixed, however, is not something we can settle by philosophy alone. It depends on what physics ultimately says about determinism, and on that question, the block universe of relativity is not the only voice. There is a rival picture, one that accepts much of the eternalist framework, but insists on a crucial difference. A picture in which the past and present are real, but the future genuinely does not yet exist. To understand the full landscape of possibilities, and to test the block universe against its strongest competitors, we need to examine this alternative, the model known as the growing block, and see whether it offers a way to keep the open future that the static block seems to deny. The growing block universe accepts a great deal of what the static block proposes, but it makes one decisive change, and that change is designed to rescue the open future. In the growing block, the past and the present are real. Every event that has happened, from the beginning of the cosmos up to this moment, exists as part of the structure, fixed and definite. But the future does not exist. It is not laid out ahead, waiting at coordinates we have not reached. It is genuinely unmade, non-existent, an emptiness into which reality is continually expanding. The loaf, in this picture, is not complete. It is growing, with new slices being added at the leading edge, the edge we call the present. The present is the boundary where reality is actively coming into being, the growing tip of an expanding block. This model has an immediate intuitive appeal, because it preserves several features of ordinary experience that the static block discards. It keeps the past as real, which matches our sense that what has happened genuinely happened and is now settled. It keeps the future open, which matches our sense that tomorrow is not yet determined, that the possibilities ahead are real possibilities. And it gives the present a special status, which matches the overwhelming feeling that this moment, the now, is uniquely real in a way that other moments are not. In the growing block, the present is special. It is the edge of existence, the frontier where the non-existent future is being converted into the existing past. The flow of time becomes the growth of the block, the steady addition of new reality at the advancing edge. This is a picture in which becoming is real, in which the universe is genuinely doing something, accumulating existence moment by moment. For these reasons, the growing block has attracted serious defenders, and it represents one of the main alternatives to the static eternalist view. But it faces severe problems, and the most serious of them come once again from relativity. Recall the central lesson of the relativity of simultaneity. There is no universal present, no single slice of the cosmos that everyone agrees is happening now. The present depends on the observer's state of motion. Different observers slice space-time at different angles, and their planes of simultaneity disagree about which distant events are present. But the growing block requires a universal present. It requires a single, objective edge where reality is being added, a definite boundary between the existing past and the non-existent future. And relativity says no such universal boundary exists. The edge of the growing block would have to be one particular slice. But relativity insists that no slice is privileged, that the choice of present is a matter of perspective. The growing block needs an objective now, and relativity denies that there is one. This is a deep tension, and it is difficult for the growing block to escape. If the edge of reality is defined by one observer's plane of simultaneity, then observers in different states of motion would disagree about where the edge is, about which events have come into existence and which have not. One observer's real present event might lie beyond another observer's edge, in what that second observer considers the non-existent future. Reality itself would fracture, with events existing for some observers and not for others, depending on their motion. This is incoherent in a way the static block avoids. The static block has no privileged present to disagree about, so the relativity of simultaneity poses no problem. All slices are equally real, so it does not matter that observers slice differently. The growing block, by insisting on a real objective edge, runs directly into the relativity of simultaneity and struggles to define what its edge could even be. Defenders of the growing block have responses, of course. Some propose that there is, after all, a privileged frame of reference, a true cosmic present, even though relativity treats all frames as equivalent. They point out that the universe as a whole does seem to provide a natural reference frame, the frame in which the cosmic microwave background radiation, the afterglow of the Big Bang, looks uniform in all directions. In this cosmic rest frame, there is a sense in which a universal time can be defined, a time since the beginning that applies to the cosmos as a whole. Perhaps the edge of the growing block follows this cosmic time, providing the objective present that relativity seemed to forbid. This is a genuine response, but it comes at a cost. It requires treating one frame as truly special, as the real frame, contradicting the spirit of relativity, even if not its letter. It reintroduces something like the absolute time that Einstein abolished, and many physicists are reluctant to take this step without strong, independent reason. There is a further difficulty with the growing block, one that is more philosophical but no less pointed. It concerns how an observer within the growing block could know that they are at the edge. Consider any moment in the past, say a moment a year ago. At that moment, that slice was the edge of the growing block, the present, the leading tip of reality. The version of you a year ago felt that their moment was the present, the now, the real edge. But now that moment is no longer the edge. It has been buried under a year of subsequent growth, yet it still exists as a real part of the past. And here is the problem. The version of you a year ago felt exactly as present, exactly as much at the edge as you feel now. From the inside, every moment in the growing block feels like the edge, because every moment was the edge when it was the present. So how do you know that this moment, right now, is really the edge, and not some buried past moment that merely feels like the edge the way all moments do. You have no way to tell. Your conviction that you're at the present edge is identical to the conviction that every past version of you had, and most of those were wrong, since they are now in the past. This undermines the very thing the growing block was supposed to secure, the special reality of the present. This argument, sometimes raised against the growing block, cuts surprisingly deep. It suggests that the feeling of being at the present edge cannot be used as evidence that one actually is at such an edge, because the feeling is present at every moment, including moments that are now firmly in the past. And if the feeling of presence is universal across all moments, then it provides no reason to think there is a special present edge at all. This pushes back toward the static block, where every moment contains observers who feel present, and none is privileged. The growing block tried to honor the special status of the now, but it cannot explain why this now, as opposed to all the past nows that also felt present, is the real edge of reality. Despite these difficulties, the growing block remains a live option, and it is valuable precisely because it isolates what is at stake. The disagreement between the static block and the growing block is, at its core, a disagreement about whether the future exists. Both agree the past is real. Both agree the present is real. The question is whether tomorrow, in all its detail, is already laid out, or whether it is genuinely unmade, waiting to be brought into existence at the advancing edge. This is not a question that armchair reasoning can easily settle. It turns on the deepest features of physical reality, on the nature of time in relativity, on the interpretation of quantum mechanics, on cosmology, and the structure of the universe as a whole. The growing block and the static block represent two coherent ways the world might be, and at present, we do not have a decisive experiment to choose between them. But there is a third position we have not yet given its full hearing, and it represents the strongest challenge to eternalism of any kind. Both the static block and the growing block agree that the past is real, that yesterday still exists somewhere in the structure. There is a view that denies even this, that holds only the present moment exists, that the past is gone and the future is not yet, and that reality consists of nothing but this single, fleeting now. This is the view that matches common sense most closely of all, the view almost everyone holds without realizing it is a philosophical position at all. To complete the landscape and to test eternalism against its deepest rival, we must turn to this last contender and ask whether the present, and only the present, might be all that there truly is. The view is called presentism, and it is, in a sense, the natural philosophy of the human race. Almost everyone, before they encounter the arguments of physics, believes it without question. Presentism holds that only the present moment exists. The past existed, but it does not exist now. It is gone, vanished, retained only in memory and record, but not in reality. The future will exist, but it does not exist yet. It is not yet real, merely a set of possibilities that have not arrived. All that exists on this view is the present, the thin slice of now, continuously replacing itself as one moment gives way to the next. Reality is not a loaf, static or growing. It is a single moving slice, and nothing else. What we call the past is just the trail of slices that have ceased to be, and the future is the slices not yet born. This matches ordinary experience so closely that it can be hard to see it as a theory at all. When you think of a person who died years ago, you naturally think of them as no longer existing. When you think of your own future, you think of it as not yet real, as something that has not happened. These are presentist intuitions, and they run so deep that the Eternalist claims that the dead still exist somewhere in the loaf, that the future is already laid out, strike most people as obviously absurd on first hearing. Presentism is the default, the position we all start from, and any view that departs from it carries the burden of overcoming a lifetime of intuition. So it is worth giving presentism its strongest case before weighing it against the alternatives. The presentist has a ready response to the feeling of time's flow, and it is a response that turns the tables on eternalism. The eternalist must explain why we feel time passing if the universe is really static, and this requires the elaborate story about the brain constructing the sensation of flow. The presentist needs no such story. For the presentist, time really does flow, because the present really does move. The feeling of passage corresponds to something real, the continuous replacement of one present by the next. We feel time flowing because time flows. The eternalist account, by contrast, must treat the most immediate feature of experience as an illusion requiring complicated explanation. The presentist can say more simply that experience is telling us the truth. Reality is dynamic, the present is real and moving, and the feeling of flow is an accurate perception of how things actually are. There is an economy and a naturalness to this that should not be dismissed. Presentism also handles the special status of the present effortlessly, where eternalism struggles. We feel that this moment is uniquely real, vividly present in a way that other moments are not. For the eternalist, this feeling is a puzzle, since all moments are supposed to be equally real, and the special vividness of the present has to be explained away as a feature of experience that every moment shares. For the presentist, the special status of the present is no illusion at all. The present is special because the present is all that exists. Of course, this moment feels uniquely real. It is uniquely real. The feeling matches the metaphysics perfectly. There is no gap to bridge, no illusion to explain. The presentist takes experience at face value and builds a metaphysics that honors it, where the eternalist must repeatedly tell us that our deepest temporal intuitions are mistaken. These are real strengths, and they explain why presentism remains a defensible position held by serious philosophers, not merely a naive view to be discarded. But presentism faces a formidable adversary, and that adversary is relativity. The trouble is the same one that haunted the growing block, only sharper. Presentism requires a single, objective present. Reality consists of the present moment and nothing else, which presupposes that there is a definite fact about which moment is the present, a single now that constitutes the whole of existence. But relativity, as we have seen at length, denies that there is any such universal present. The now is relative to the observer's motion. Different observers have different planes of simultaneity, different slices they regard as present. If reality consists only of the present, but the present differs from observer to observer, then reality itself would differ from observer to observer, which is incoherent. There must be a single reality, but presentism ties reality to a present that relativity refuses to make singular. This objection is severe, and it is the main reason many physicists and philosophers regard presentism as untenable in light of modern physics. The relativity of simultaneity seems to show that there is no privileged present, and presentism cannot survive without one. If you and I are moving differently, and reality for each of us consists of our respective presents, then we inhabit different realities containing different sets of events. Worse, by the Andromeda-style argument, an event that is real for me, because it is in my present, might be future for you, and therefore not yet real on your account. The same event would both exist and not exist, depending on who is asked. This is not a tension that can be smoothed over. It strikes at the coherence of the presentist position, which depends entirely on there being a single, shared, objective present that everyone occupies together. The presentist, like the growing block theorist, has responses available, and they parallel the earlier ones. The most common is to bite the bullet and accept a privileged frame of reference, a true cosmic present, even though relativity treats all frames as equivalent. The presentist can argue that relativity tells us about what we can measure, about the operational relationships between observers, but not about the ultimate nature of reality. Perhaps there is a real, objective present, the genuine now of the universe, even if the structure of relativity prevents us from detecting which frame it belongs to. On this view, the relativity of simultaneity is an epistemic limitation, a fact about what we can know, rather than a metaphysical fact about what exists. There really is a universal present. We just cannot single it out experimentally, because the physics hides it from us. This preserves presentism at the cost of positing something undetectable, a hidden, privileged frame that does the metaphysical work while remaining forever invisible to measurement. Whether this move is acceptable is a matter of judgment, and reasonable people disagree. Critics say it is an unacceptable retreat, positing an undetectable structure purely to save a threatened theory, in violation of the principle that we should not multiply unobservable entities without necessity. They point out that relativity was a triumph precisely because it eliminated the undetectable absolute time of Newton, and that reintroducing it through the back door to rescue presentism undoes that achievement. Defenders reply that physics has often posited unobservable structures that later proved fruitful, and that the demands of metaphysics are not identical to the demands of measurement. The debate continues, unresolved, and it illustrates a recurring feature of these questions. The physics constrains our options powerfully, but it does not always determine a single answer. Interpretation enters, and with it the possibility of reasonable disagreement among people who accept all the same experimental facts. What emerges from this survey of positions is a clearer sense of the true situation. We have three main contenders. The static block, Eternalism proper, holds that all moments exist equally, past, present, and future, in a complete four-dimensional structure. The growing block holds that past and present exist, but the future does not, with reality expanding at an advancing edge. Presentism holds that only the present exists, with past and future both unreal. Each captures some of our intuitions and violates others. Each has resources to respond to objections, but they are not equally favored by the physics. Relativity, with its denial of a universal present, presses hard against both the growing block and presentism, since both require a privileged, now that relativity declines to provide. The static block, alone among the three, needs no privileged present, and so it sits most comfortably with relativity as we currently understand it. This is the central reason eternalism is taken seriously, not because it is intuitive, for it is not, but because it fits the structure of our best physical theory with the least strain. And yet the matter is not closed, because relativity is not our only fundamental theory. There is quantum mechanics, the physics of the very small. And quantum mechanics has its own things to say about time, determinism, and the reality of the future. In some respects, quantum mechanics seems to support the eternalist picture, but in other respects, it seems to resist it, introducing genuine indeterminacy where the block universe suggests a fixed structure. The relationship between relativity and quantum mechanics is one of the great unsolved problems in physics, and the nature of time sits squarely at the center of that unsolved problem. To understand how secure the block universe really is, we have to confront what happens when the smooth, deterministic space-time of relativity meets the probabilistic, uncertain world of the quantum. Quantum mechanics introduces a complication that the block universe of relativity does not on its own anticipate. In relativity, the future is laid out as definitely as the past, every event fixed at its coordinates, the loaf complete and unchanging. This picture sits naturally with a deterministic view of the world, in which the state of any slice, together with the laws of physics, fixes the contents of every other slice. But quantum mechanics appears to break this determinism. At the smallest scales, the outcomes of certain events are not fixed in advance. They are governed by probabilities, and the probabilities do not resolve into certainties until a measurement is made. Before the measurement, the system exists in what is called a superposition, a combination of multiple possible outcomes, none of them yet actual. The measurement seems to select one outcome from the range of possibilities, and which one it selects appears to be genuinely random, not determined by anything in the prior state of the world. Consider the standard example, a radioactive atom that may or may not decay. Quantum mechanics does not tell you when a particular atom will decay. It tells you only the probability that it will decay within a given span of time. The atom has a certain chance of decaying in the next hour, and a certain chance of remaining intact. And there is, according to the standard interpretation, no hidden fact that determines which will happen. The outcome is not written anywhere in advance. It is settled only when it occurs, and it could have gone the other way. If this is correct, then the future is not fixed by the past. The contents of the future slices are not computable from the present one, because the quantum events that populate those slices are genuinely undetermined until they happen. This seems to directly contradict the block universe, which presents the future as already there, already definite, already real. The tension is real, and it lies at the heart of one of the deepest unsolved problems in physics, the problem of reconciling quantum mechanics with relativity. But the situation is more nuanced than a simple contradiction, and a great deal depends on how quantum mechanics is interpreted. The mathematics of quantum mechanics is not in dispute. It makes precise predictions, confirmed to extraordinary accuracy. What is in dispute is what the mathematics means, what picture of reality lies behind the successful predictions. And different interpretations of quantum mechanics relate to the block universe in very different ways. Some sit comfortably with eternalism. Others seem to demand a dynamic, open future of the kind the block denies. The question of whether the block universe is correct turns out to be entangled with the question of how to interpret the quantum world, and that question remains unsettled after a century of debate. Take first the interpretation that most threatens the block, the standard view in which measurement causes a real, random collapse of the superposition into a single, definite outcome. On this view, before measurement, the system genuinely lacks a definite value, and the measurement genuinely creates one, selecting randomly among the possibilities. This is a fundamentally dynamic picture. The future is open because the outcomes of measurements are not yet decided. Reality is being generated moment by moment as collapses occur and possibilities become actualities. This fits poorly with the static block, in which everything is already laid out. If collapse is a real physical process that genuinely selects outcomes, then the future cannot be sitting there fully formed, because the events that will populate it have not yet been decided. The collapse interpretation pushes towards something more like a growing block or an open future, in which becoming is real and the loaf is not complete. But there is another major interpretation, and it points in the opposite direction entirely. This is the many worlds interpretation, which takes the mathematics of quantum mechanics at face value and refuses to add any collapse at all. On this view, the superposition never collapses. When a measurement occurs, all the possible outcomes happen, each in its own branch of reality. The universe splits, or rather, it was always a vast branching structure, and the measurement simply reveals which branch a given observer finds themselves in. The atom both decays and does not decay, in different branches. You who observe the decay, and you who observe the non-decay, both exist, in different branches, each unaware of the other. On this interpretation, nothing is ever genuinely undetermined in the way the collapse picture suggests. Every possibility is realized, and this fits remarkably well with the block universe, because the entire branching structure, all the branches together, can be regarded as a single, static, four-dimensional, or higher dimensional whole. The many worlds interpretation is, in a sense, an even larger block, a block that includes every possible outcome of every quantum event, all coexisting, all equally real. In the many worlds picture, the appearance of randomness and an open future is, like the flow of time, a feature of the observer's limited perspective. You experience a single definite outcome and feel that it was selected randomly from the possibilities, that it could have gone otherwise, and the matter was genuinely open. But in reality, all outcomes occurred in different branches, and your sense of a single random result reflects only that you are one particular version of yourself, located in one particular branch. The other versions in the other branches experience the other outcomes. The total structure is fixed and complete, containing all branches. Nothing is undetermined when the whole structure is taken into account. The openness of the future is, once again, relocated from the world into the observer. This interpretation, embraced by many physicists precisely because it removes the awkward, ill-defined collapse process, is deeply compatible with eternalism. It extends the block to encompass all quantum possibilities, preserving the static, complete character of reality at the cost of an enormous proliferation of coexisting worlds. So quantum mechanics does not deliver a single verdict on the block universe. It delivers different verdicts under different interpretations. Under collapse interpretations, the block is threatened, and the future appears genuinely open. Under many worlds, the block is vindicated and even enlarged. Under still other interpretations, the picture is different again. There are interpretations in which the quantum state is not a description of reality at all, but a description of our knowledge, leaving the underlying reality possibly deterministic and block-like beneath the probabilistic surface. There are interpretations involving hidden variables, in which the apparent randomness conceals an underlying determinism, again potentially compatible with a fixed future. The landscape is complex, and which interpretation is correct is not known. The experiments do not distinguish among them because they all reproduce the same predictions. The choice among them is, at present, a matter of theoretical preference and philosophical argument rather than empirical test. There is, however, a further consideration that bears on the block universe specifically, and it comes from attempts to combine quantum mechanics with relativity into a single consistent theory. Relativity, with its space-time structure, strongly favors a block-like view, treating time as a dimension and resisting any privileged present. When physicists construct quantum field theory, the framework that successfully merges quantum mechanics with special relativity, they build it on the space-time of relativity, the block. Quantum field theory is formulated on a fixed space-time background, and it works extraordinarily well, underlying our understanding of particles and forces. In this framework, there is no fundamental collapse and no privileged present. The dynamics are described in a way that respects the relativistic structure, the block. This suggests that at the level of our most successful unified theory, the block universe is the natural setting, and the apparent collapse and openness of the everyday quantum picture are features of how the theory is applied and interpreted rather than fundamental features of reality. Yet this cannot be the final word, because quantum field theory does not include gravity, and gravity is precisely where relativity's space-time becomes dynamic and intricate. The deepest unsolved problem in physics is the construction of a theory of quantum gravity, a theory that would unite the quantum world with the general theory of relativity, in which space-time itself bends and curves and participates in the dynamics. In some approaches to quantum gravity, the very notion of time as we understand it dissolves. Certain equations describing the quantum state of the entire universe contain no time variable at all, a startling result that suggests time may not be fundamental but emergent, arising somehow from a deeper, timeless structure. If time itself is not fundamental, then the question of whether the future exists may be more subtle than either eternalism or its rivals assume. The block universe presupposes a space-time within which events are laid out. But if space-time itself emerges from something more basic, the entire framework may need rethinking. This is the frontier, and it is genuinely open. We do not have a complete theory of quantum gravity, and until we do, the ultimate nature of time remains uncertain. What we can say is that the block universe is strongly supported by relativity, compatible with at least some major interpretations of quantum mechanics, and embedded in the structure of our most successful unified theories. But it is challenged by collapse interpretations, complicated by the measurement problem, and potentially transformed by whatever theory of quantum gravity eventually emerges. The eternalist picture is not a proven fact. It is a powerful and well-motivated interpretation, sitting at the intersection of our deepest theories, neither confirmed nor refuted, awaiting the deeper understanding that a complete physics might provide. And this uncertainty, this genuine openness at the foundations, is worth holding in mind as we return to the question with which we began. The question of what all this means for a single human life, and for its end. We began with Einstein, and it is to Einstein that we now return, because he confronted the personal meaning of these ideas directly, in circumstances that gave them weight. In the spring of 1955, Einstein's lifelong friend Michel Besso died. The two had known each other for decades, since their days as young men, and Besso had been a sounding board for some of Einstein's earliest thinking about relativity. When Besso died, Einstein wrote a letter to his family, and in that letter, he expressed something that has become one of the most quoted passages in the literature on the nature of time. He wrote that for those who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. Einstein himself would die just weeks later, and so these words stand near the very end of his own life, a statement of what his physics implied about death, offered in consolation to the bereaved, and perhaps to himself. It is important to understand what Einstein was actually saying, because the sentiment is easily misread as mere poetic comfort, the kind of thing one says to soften grief without meaning it literally. But Einstein meant it literally, or at least as literally as the physics allows. The distinction between past, present, and future being an illusion is precisely the claim of the block universe. If all moments exist equally, if the loaf is complete, and Besso's life occupies a permanent region of it, then Besso has not been annihilated. His death is the far end of his world line, the last slice of his particular ribbon through space-time, but the ribbon itself remains, every moment of it as real as it ever was. Besso's birth, his childhood, his friendship with Einstein, his work, his ordinary days, all of these still exist, fixed at their coordinates in the structure of reality. From the perspective of the block as a whole, Besso has not ceased to be. He is simply located in regions of the loaf that the living can no longer reach. This is the reframing of death that Eternalism offers, and it is worth examining carefully, because it is both genuinely consoling in one respect and genuinely limited in another. The consoling aspect is that nothing that exists is ever truly lost. In the ordinary view, death is annihilation. The person who dies passes out of existence entirely, leaving only memories in the minds of others and traces in the physical world. The presentist view makes this stark. Once the present moment moves past a person's death, that person no longer exists in any form. They are gone, absolutely. The block universe denies this. The person who has died still exists, in the only sense in which anything exists according to Eternalism, namely as a real part of the four-dimensional structure. Their life is not erased by their death. It remains permanent and complete. Every joy they experienced, every moment of their existence, is eternally real, fixed forever in the loaf. Death, on this view, is not the annihilation of a life, but the boundary of it, the edge where the world line ends, beyond which the person does not extend, just as their world line had a beginning before which they did not extend. There is a particular way of putting this that captures its character. A human life in the block universe is like a book. The book has a first page and a last page. The story begins and the story ends, but the ending of the story does not erase the earlier pages. When you finish reading a book, the chapters you have read do not cease to exist. They remain part of the book, as real as the final chapter. The book is complete, all its pages present at once between the covers, even though when reading you encounter them one at a time. A life in the block universe is a complete book of this kind. Its last page is death, but the book exists in its entirety, every page permanently part of it. The person who reaches the end of their life has not been deleted. They have been completed. Their existence is finished in the sense that a book is finished, whole and entire, not in the sense of having been destroyed. This connects to the question posed in the title of this inquiry, the question of whether you have already reached the end of your life. In the block universe, the answer has a strange double character. In one sense, yes. If the loaf is complete, then the slice containing your death already exists, as real as the slice containing this moment. The end of your life is already there, fixed at its coordinates, a permanent feature of reality. You have, in this sense, already reached it, because it is already real, already part of the structure, already as actual as your birth. From the perspective of the block as a whole, your entire life, from first moment to last, exists all at once, and the end is no less present than the beginning. There is no sense in which your death is waiting to happen in some absolute future that does not yet exist. It exists now in the only sense eternalism grants to existence. But in another sense, the answer is no, and this is where the consolation becomes more subtle and the picture more humane than it might first appear. Although the slice containing your death exists, you do not experience all your slices at once. Each momentary version of you experiences only its own slice, with its own present, its own vivid now. The version of you reading this is located at this slice, experiencing this moment, with no access to the slice containing your death. From the inside, from the perspective of any particular moment of your life, you are always located somewhere within the book, never at a vantage point that takes in the whole. You experience your life sequentially, moment by moment, each moment feeling like the present, even though all the moments exist together. So while it is true that the end of your life already exists in the loaf, it is not true that you, as you are now, have experienced it. You are here at this page, and the experience of this page is all you have. The end exists, but you are not at it. You are here. This dissolves a certain kind of dread that the block universe might otherwise seem to produce. One might fear that if the future already exists, then we are somehow already dead, that the reality of our death somehow reaches back and diminishes the life we are living now. But this does not follow. The reality of the final page does not diminish the reality of the page you are on. Each page is fully real, fully present to the version of you that occupies it, regardless of what other pages exist. The existence of your death does not make your present any less alive. You are completely, vividly present at this moment, experiencing it fully, and the fact that other moments also exist, including your last, takes nothing away from the reality and richness of this one. The block universe does not make the living already dead. It makes every moment of life eternally, permanently alive, fixed forever in the structure, never to be erased. There is something in this that genuinely shifts the emotional weight of mortality, even if it cannot remove it entirely. The ordinary fear of death is, in large part, a fear of annihilation, of passing into nothingness, of one's existence being utterly extinguished. The block universe offers a different picture, in which existence is not extinguished, but bounded. You do not become nothing. You remain eternally, as the complete pattern of your life within the loaf. The fear of becoming nothing is met with the assurance that you do not become nothing, that what you are is permanent, that the moments of your life are indestructible features of reality. This is not the same as immortality. The block universe does not promise that your world line continues beyond your death, that you go on experiencing new moments forever. Your book has a last page, and there is no page after it. But the book itself is eternal. Nothing in it is ever lost. Whether this constitutes real consolation is, in the end, a personal question, and honesty requires acknowledging its limits. For some, the permanence of their lived moments within the block is a genuine comfort, a way of seeing that nothing precious is ever truly destroyed, that every moment of love and experience is woven permanently into the fabric of what is. For others, this is cold comfort, because what they want is not the eternal existence of past moments, but the continuation of experience, more pages in the book, and this the block universe does not provide. Einstein, by all accounts, found the view consoling, or at least found in it a way of accepting death that was consistent with his understanding of the physics he had spent his life developing. He faced his own death, weeks after writing to Besso's family, with notable equanimity. Whether that equanimity flowed from his physics or from his character is impossible to say. But the connection he drew between the structure of space-time and the meaning of mortality was sincere, and it points to a way that these abstract questions about the nature of time touch the most concrete fact of every human life, the fact that it ends. And if it is true that the end already exists, then the question becomes how one might live, knowing that every moment, including this one, is permanent and complete. If the block universe is correct, the natural next question is whether it should change anything about how a person lives. Some ideas in physics are purely theoretical, with no bearing on ordinary life. The existence of distant galaxies, the behavior of subatomic particles. These are fascinating, but they do not obviously alter how one ought to spend a Tuesday afternoon. The block universe is different because it makes claims about the reality of every moment, including the moments of your own life, and claims about the permanence of those moments. Whether or not one finds it consoling in the face of death, the picture has potential implications for how one regards the present, the past, and the choices one makes. It is worth thinking through what those implications might be, while being careful not to overstate them, because the block universe is an interpretation, not a settled fact, and any conclusions drawn from it inherit that uncertainty. Begin with the permanence of the past. In ordinary thinking, the past is gone, and this goneness colors how we regard our own histories. Moments of happiness, once they pass, seem lost, retrievable only through the imperfect medium of memory. The good times are over, we say, as though they have been deleted from reality. The block universe suggests a different relationship to one's own past. Those moments are not gone. They exist permanently at their coordinates in the loaf. The happiest day of your life is still there, as real as it ever was, occupied by the version of you that lived it, experiencing it fully. This does not mean you can return to it, any more than you can walk to a distant city you once visited and find your past self still there. But it does mean that the moment was not provisional, not a temporary flicker now extinguished. It was a permanent addition to reality, indestructible. There is a way of regarding one's own life under this view, in which nothing good is ever truly lost, only located in a part of the structure one can no longer visit. This cuts both ways, of course, and intellectual honesty requires noting it. If the happy moments are permanent, so are the painful ones. The block universe does not erase suffering any more than it erases joy. The worst moments of a life are also fixed at their coordinates, also permanent features of reality. For someone carrying difficult memories, the thought that those moments are eternally real, never to be undone, might be unwelcome rather than consoling. But there is a counterweight to consider. In ordinary thinking, past suffering casts a long shadow, partly because we feel we are still moving away from it, that it defines a trajectory we are stuck on. The block universe relativizes this. The suffering is real at its coordinates, but so is every other moment, including moments far removed from the suffering, moments of recovery, of peace, of ordinary contentment. No single moment defines the whole. The life is the entire book, and the difficult chapters, while permanent, are not the whole story. The block universe does not privilege the painful moments over the good ones. All are equally real, and the life entire, with all its texture, is what exists. There is a further consideration that some have drawn from the block universe, concerning the weight and significance of choices. One might worry that if the future already exists, then choices do not matter, that there is no point in trying, since the outcome is already fixed. We addressed the philosophical version of this worry earlier, distinguishing the block universe from fatalism and noting that choices remain causally effective even in a fixed future. But there is an emotional or practical version of the worry that deserves separate attention. Even granting that choices are causally effective, does the knowledge that the future already exists drain the motivation from action? Here the answer seems to be that it need not, and perhaps should not. The future depends on your choices, precisely because your choices are part of the structure that determines it. The fact that the result already exists does not mean it exists independently of what you do. It exists because of what you do. Your effort is not pointless. Your effort is the very thing that shapes the outcome, woven permanently into the loaf as a real cause of real effects. In fact, there is a way in which the block universe might enhance, rather than diminish, the significance of action. If your choices are fleeting events that vanish the moment they are made, leaving only their consequences, then there is a sense in which the choices themselves are ephemeral, gone as soon as done. But in the block universe, your choices are permanent. The moment of decision, the act of will, the effort you make, all of these are eternal features of reality, fixed forever at their coordinates. You are not writing in sand that the next wave will erase. You are writing in something indelible. Every act of courage, every kindness, every moment of integrity is a permanent addition to the structure of reality, never to be undone. This can be seen as conferring a kind of weight on action, a permanence that the ordinary view, with its vanishing present, does not provide. What you do becomes part of the eternal furniture of the universe, as enduring as anything else in it. There is also a particular orientation toward the present that the block universe might encourage, though here one must be especially careful, because it is easy to slide from physics into mere self-help, and the connection becomes loose. Still, the thought is worth stating. If every moment is equally real, and if the only moment any version of you ever experiences is the one it is in, then there is a sense in which the present moment is all you ever have, not because the past and future are unreal, but because experiencing is always local to a slice. The version of you that exists now experiences now, fully and completely, and this is true of every version of you at every moment. This might encourage a certain attention to the present, an appreciation that this moment, the one being experienced, is a complete and real thing in itself, not merely a step towards some future moment that matters more. Each slice is fully real, fully itself. The future moments will be experienced by the versions of you that occupy them, but this moment is experienced by you now, and it is no less real or significant for being one slice among many. It must be admitted that these reflections are speculative in a different way from the physics. The block universe, as a description of space-time, rests on relativity and on careful argument. The implications for how to live rest on much looser reasoning, on analogies and interpretations that go well beyond what the physics strictly entails. A person could fully accept the block universe as a physical description and draw none of these life lessons from it, or draw entirely different ones. The physics constrains the metaphysics, but the metaphysics does not dictate a way of life. What the block universe offers is a different frame, a different way of picturing one's existence, and what a person makes of that frame is up to them. Some will find in it a deepened appreciation for the permanence of their lived experience. Others will find it a curiosity with no bearing on how they go about their days. Both responses are coherent. What seems clear is that the block universe, if true, is not a doctrine of despair. It does not say that life is meaningless, or that choices do not matter, or that the present is unreal. It says something closer to the opposite. It says that every moment of your life is permanently real, that nothing you experience is ever truly lost, that your choices are eternal features of reality, and that the present you are living is as real as anything in existence. The unease the picture can provoke, the sense that a fixed future somehow robs life of its openness, tends to dissolve on closer examination, replaced by something more like a sober appreciation of permanence. Whether this appreciation rises to the level of consolation or remains merely an interesting reframing depends on the person. But the picture itself, properly understood, is more affirming than the initial shock of it suggests. The loaf is not a prison. It is a record, complete and indestructible, of everything that is. And so we arrive at the threshold of a final reckoning, the point at which we must gather what we have found and weigh it honestly. We have followed the block universe from its origins in the constancy of light, through the relativity of simultaneity, the Andromeda paradox, the structure of the loaf, the puzzles of the arrow of time, and the flow of experience, the challenge to free will, the rival models of growing block and presentism, the complications introduced by quantum mechanics, and the implications for death and for living. We have seen where the picture is strong and where it is uncertain. What remains is to ask, finally, how much of this we should believe, and what it would mean to take seriously the possibility that the question we began with, whether you have already reached the end of your life, has an answer that physics cannot quite let us escape. We have traveled a long way from the simple image of time as a flowing river, and it is worth pausing to take honest stock of what the journey has actually established and what remains genuinely open. It would be a disservice to pretend that the block universe is proven, settled science, a fact on the order of the roundness of the Earth or the existence of atoms. It is not. It is an interpretation, a way of understanding what our best physical theories imply about the nature of time. And like all interpretations, it goes beyond the bare equations into territory where reasonable people, including expert physicists and philosophers, continue to disagree. At the same time, it would be equally misleading to dismiss it as idle speculation, untethered from evidence. The block universe is the most natural reading of relativity, supported by the deepest and most thoroughly confirmed theory of space and time we possess. The truth sits in the difficult middle, and locating it precisely is the task of this final reckoning. Consider first what stands on the firmest ground. The relativity of simultaneity is not in doubt. It is a direct consequence of the constancy of the speed of light, and it has been confirmed in countless experiments, from the behavior of fast-moving particles to the precise timing corrections built into the global positioning system, which would fail within hours if the effects of relativity were not accounted for. There is no serious question that simultaneity is relative, that different observers in different states of motion genuinely disagree about which distant events happen at the same time, and that there is no experiment capable of declaring one of them correct and the others mistaken. This is established physics, as solid as anything in science. The denial of a universal present is not speculation. It is a confirmed feature of the world we live in. From this confirmed foundation, the argument for the block universe proceeds with considerable force. If there is no universal present, if the now fractures into different versions for different observers with none privileged, then the comfortable picture of a single advancing moment, shared by all of reality, cannot be maintained. Something must replace it, and the block universe is the most coherent replacement on offer. It accommodates the relativity of simultaneity effortlessly, because it grants no special status to any slice, treating all moments as equally real and leaving the choice of present entirely to the perspective of the observer. The rival views, presentism and the growing block, both require a privileged present that relativity refuses to provide, and both must therefore either contradict the physics or posit an undetectable preferred frame to rescue themselves. This asymmetry is the strongest single consideration in favor of eternalism. It does not prove the block universe, but it shows that the block universe fits our best physics with the least strain, while its rivals must strain considerably to survive. Yet the argument is not airtight, and intellectual honesty requires marking the gaps clearly. The step from the relativity of simultaneity to the full block universe relies on a philosophical premise. The premise that what is real for any valid observer must be real without qualification, that reality cannot be relative to perspective in the way the present is. This premise is reasonable, even compelling, but it is not forced by the physics alone. A determined defender of presentism can reject it, accepting that reality itself is, in some sense, perspectival, or positing a hidden preferred frame that grounds an objective present beneath the relativistic surface. These moves carry costs, and many find those costs too high, but they are not strictly refuted by experiment. The block universe is the most natural conclusion, but it is a conclusion reached through interpretation, and the interpretive step is where the certainty of the physics gives way to the judgment of the thinker. The complications from quantum mechanics deepen this uncertainty rather than resolving it. We saw that the relationship between quantum mechanics and the block universe depends heavily on which interpretation of quantum mechanics one adopts. Under the many worlds interpretation, the block is vindicated and even enlarged, encompassing every quantum possibility in a vast static structure. Under collapse interpretations, the future appears genuinely open, and the block is threatened by the apparent reality of random, undetermined outcomes. The quantum measurement problem, the question of how and whether superpositions resolve into definite outcomes, remains unsolved after a century of intensive effort. And the deepest level, the unification of quantum mechanics with gravity, remains beyond our current reach, with some approaches suggesting that time itself may not be fundamental, that the space-time within which the block universe is defined may emerge from a deeper, timeless structure we do not yet understand. The block universe sits atop these unresolved questions, well supported by relativity, but exposed to revision by whatever deeper theory eventually emerges. So what should a careful person conclude? Not certainty in either direction. The honest position is that the block universe is a strong, well-motivated interpretation of our best current physics, more compatible with relativity than its rivals, supported by at least some interpretations of quantum mechanics, and embedded in the structure of our most successful unified theories. But it is not proven, and it could be overturned or transformed by advances we cannot yet foresee. To believe it with total conviction would be to overstate the evidence. To dismiss it entirely would be to ignore the powerful considerations that favor it. The appropriate stance is one of serious provisional acceptance, holding the block universe as the most likely picture given what we currently know, while remaining genuinely open to revision. This is not a comfortable resting place for those who crave definite answers, but it is the intellectually honest one, and it reflects the actual state of human knowledge about the nature of time. What then of the question we began with? The question of whether you have already reached the end of your life. In the block universe, as we saw, the answer carries a strange double character. If the loaf is complete, then the slice containing your final moment already exists, as real as the slice containing this one, fixed permanently at its coordinates. In that sense, the end of your life is already there, already real, already part of the structure of reality. You have, in this sense, already reached it, because there is no privileged present sweeping toward it, no flow that has yet to arrive. The end exists now, in the only sense eternalism grants to existence. And yet, in another sense, you have not reached it at all, because you, as you are at this moment, experience only this slice, this present, with its own vivid reality, and no access to the slice where your life ends. You are here, at this page of the book, and this page is fully real, fully alive, regardless of what other pages exist. This is the curious resolution the block universe offers to its own most unsettling question. The end of your life both already exists and has not yet been reached, depending on whether one takes the external view of the whole loaf or the internal view of a single experiencing slice. From outside, all moments coexist, and your death is as present as your birth. From inside, you're always somewhere within the structure, always experiencing a particular now, never occupying the whole at once. Both perspectives are valid. The external view is the view of physics, the loaf seen as a complete four-dimensional object. The internal view is the view of experience, the perspective of a conscious being embedded in the loaf, living one moment at a time. The block universe does not force you to choose between these. It says that both are true, that reality is the static whole, and that experience is the local, sequential traversal of it, and that there is no contradiction in holding both, because they are simply two ways of regarding the same four-dimensional fact. Perhaps this is where the inquiry properly ends, not with a definitive answer, but with a transformed understanding of the question. Whether the block universe is ultimately correct remains uncertain, awaiting the deeper physics that might confirm or overturn it. But the picture it offers is coherent, well-grounded, and profound in its implications. It suggests that the time we experience as flowing is, at the level of fundamental reality, a static structure, and that the moments of our lives, far from vanishing into non-existence as they pass, remain permanently real, fixed forever in the fabric of what is. If this is true, then nothing you have ever experienced is lost. Your choices are eternal, and the end of your life, while real, is only the boundary of a book whose every page endures. And if it is not true, if some deeper theory restores the flow of time or the openness of the future, then the questions raised along the way will have sharpened our understanding regardless, forcing us to confront what we mean by past, present, future, existence, and the strange, undeniable fact that we find ourselves here, now, at this particular slice, experiencing this particular moment, wondering about the structure of the time that carries us. The answer to whether you have already reached the end may be one that physics cannot yet give. But the question itself has shown us how little we truly understand about the most familiar thing in all of human experience, the passage of time, and how much remains to be discovered at the foundations of reality, where the nature of time still waits, like so much else, to be fully understood.